When I applied for this job, I had to send a video of a lecture, and I sent the video of this lecture, and one of my colleagues said, I like the fact that you mentioned beer. And I was like, oh, good. I feel, let me tell my students that so they have even more confidence in my ability. I work here because I like beer. But this is not in any way me suggesting an experiment for you to run. So don't try this. But does this? So the point of this should make sense. And when I show you that curve, that matching the homework versus your overall, I think most of you guys got a sense for immediately what that was trying to tell you and what to take away from it. So this is if an entire class went out drinking before a test in their 7 a.m. class the next day, maybe their test grade would be affected by how much they drank, right? Now, which one is, so there's the number of beers, so I didn't give you any scale, but 1, 2, 3, 4, 5, and the grade you made on the test the next day. So it could look like that, possibly, or it could look like this, possibly, right? Which one of these two would you say is a stronger relationship, a stronger fit?
The right one.
The second one. Because it lines up more. As the beers increase, the grade goes down almost perfectly. You can see the slope. You can see a straight line forming through there really easily. Now here, you can still sort of see a straight line, but it won't be perfect, especially because of who's. Who in there is what I would call an outlier? There's two of them, yeah. This is an outlier. Whenever I say outlier, I always think about Children of the Corn. Oh, yeah, we got your woman. You ever seen that movie? You're like, oh God, Jeff, what the hell are you doing? So what is true about this person? They didn't drink a lot, but, you know, of course, being sober doesn't guarantee you're going to get an A. Right? You guys are like, I've tried everything, Jeff. I've done it at various levels of drunkenness. And what's this person all about? Drank a lot. Now, of course, everybody's got different levels of how much you can take, right? How much drink you can take, right? You got the chick from Raiders of the Lost Ark in the beginning. You remember that scene? And the guy falls over. Me, I would be out of the game really quick. I'm not the heaviest weight around. So a lot of beers, but they still did really well on the test because they knew what the hell they were doing. So this is which one of these is more true to life, probably?
The left. The left one.
Yeah, go like that. The left one is definitely more true to life. This is a tighter fit, but I wouldn't expect this to affect the grades this strongly. This means that there's a strong relationship between the two, right? And I got to be careful the way I say it. I don't know which one has an effect on which, right? Now, in this case, I have a better sense of which one has an effect on which, right? But there's also all these other variables that come into account. How much do you actually know anyway, right? How well can you hold your liquor, so forth. There's all these other variables that come into this. So this one would be more true to life. It's still, you can still imagine a line fitting this data. So the line that we're going to try to draw is what I call a visual average of the data. It's the line that tries to get as close to all the points at the same time as possible. Does that make sense? So that we call it, remarkably enough, we call it the best fit line. That's the actual name of it. That's awesome. It's the line that best fits the data. How are we doing so far? All right, I like it. So compared to where we just came out of, I think this chapter you're going to enjoy it. Right? It's not as intense as the last chapter was. So here's another example. Would you say this is a negative or a positive relationship?
Negative.
Because what's the slope?
Negative.
Beautiful, exactly. So a negative slope means there's a negative relationship. What about here?
Positive.
Yeah, so hopefully this would be positive. That would suck if it was negative, right? So again, hours studied for class and the grade made on the test that you studied for. Which one's a stronger fit?
The right.
Which one's a stronger fit?
Left.
The left one. I like it. Which one's more real to life?
Right.
Exactly. I like it. But you can still see a trend, right? So you've all heard trends. Maybe you've heard of trend lines. So when we draw that best fit line, that's a trend line. I like it. How are we doing so far? Some of you guys are like, this is making too much sense. I'm scared. Don't hug me, I'm scared. Who's ever seen that? It's So here we go. So let's get a little more formalized. So what I want to do, this is not quite like a standard deviation, but I like to think it's sort of like a two-dimensional standard deviation. What I want to do is two things. I want to figure out the equation of the line of best fit. That would be useful. Why would that be useful? For example, if I'm about to go drink some beers, I want to know a good prediction. Well, if I drink this many beers, I can predict my grade will be that. If I knew the equation of the line, right? I could just plug in 6 beers and see what that means, right? 7, maybe I don't get up in the morning. I don't know. Just come to class 3 days later. How are we doing so far? Is that cool? So I want to figure out the line of best fit, because then I can use it to make predictions. Normally, we only say that predictions will only work in the data that we know. What do I mean by that? So the one I just did is sort of going against what I just said. We normally can't go outside of the interval of data that we have, because that's the only place we've observed anything. How are we doing? So if you observe fish, right? Well, interesting life you lead. So you observe these fish, and you observe them, and you know how old they are because you look in this place, and it's got a little ageometer. I don't know, it just moves. Oh, you're 7. And as the older it gets, the longer it'll get, right? Until a certain point. So you're not going to use the line that represents growth. You're not going to use it past a certain point, or else this fish is going to take over the world. In 5 years, I predicted the fish will be 20 square miles. Holy crap. Right? Godzilla fish. Okay, so I don't know if you guys get my point there. You can only operate within the lowest, highest data point that you actually saw. Outside of there, the data has no idea if it suddenly goes, wah! So for the stock market, you can't take, oh, look at that, look at the data points. Yeah, I'm going to put a lot of money in, because the next day it might go shit. Right? So you can't use a straight line prediction past the data you've observed. I like it. Maybe. So here's what we do. So it'd be great if there was some way to find a number that would enable us to compare the strengths of different relationships. This is what I call the two-dimensional standard deviation interval. But the closer the points get to the line, the R value does something. And the further the points are from the line, the R value does something. So what's really nice is if, for this situation, R would be negative something, and it's really close to being a perfect line, right? You guys with me? So R equal -1 would be a perfect negative relationship, meaning that a straight line fits perfectly and it has a negative slope. The minute you get a little, so this is not a perfect straight line here, right? The points are not all on that line. So I might predict the R to be like -0.95 or something, right? It's not a perfect straight line, but it's really close. So what do you think is true for positive correlations? So for this one, this is pretty close to a straight line. Positive straight line? Yeah, positive 0.9 something or other. Right? How are we doing so far? Is this making sense? So what do you think is true if there's no straight line that would make any sense? The points are just all over the place. Looks like your paper has measles or something. 0. Kick ass. It's amazing how much sense it makes. So the largest R could be is 1, which means a perfect positive relationship. The smallest R could be is -1, which means a perfect negative relationship. I'm trying to think in terms of what you see. Oh, yeah, okay. Negative relation, and then 0 just means there's no linear correlation. So if I had, for example, here's the limitations of what we're going to learn in this class. If I had something look like that, R would be 0 for us, because we're going to look for linear correlation. But what kind of correlation would that have? What kind of correlation might that have? What shape is that in?
U. Parabola.
A U, a parabola. And what do you call that officially? What kind of function? It's the famous formula, the negative B, pressure minus. Yes, and what's the name?
Quadratic.
Okay, good. So this would have quadratic. This would have quadratic correlation. So again, if I was looking for linear correlation, my R would come out 0 for this. Why? There's no straight line that fits that. As according to a straight line, it's like, oh, their points are all over the place. But then if I try to fit a parabola on top, it'll go, oh, cool, look at that. It's like R equal 1 almost. It's a perfect parabola. Do you guys understand what I'm saying? So you can do parabolic, quadratic, you can do cubic, you can do logarithmic. You could do exponential regression. We're just going to do linear, right? We're only going to do linear. We're only going to try to fit straight lines to stuff. Cool. I like it. Yes, ma'am.
So you're going to tell us, like, we're going to have some kind of formula or whatever to find if it's, like, because you just put 0.9, but you're just, like, saying that as an example?
Yeah, we're going to calculate it out of the calculator, actually.
Okay.
I forgot to see if they, I think they do show the formula. I want to show you the formula once. Let me see if it's in here. No, I think this book, finally me and the book agree. Everywhere it's been, use your calculator. No, damn it. And this is the one place where I want to use your calculator, so I don't think they even show you the formula. Here it is. Okay, you ready? All right. All right. Here it comes. You ready? You only have to look at this once. Now, let's just look at this for a second. We're not going to use this because, to me, it's got so much in it that it kind of goes counter to. It's not a very conceptual equation. I wouldn't call it a conceptual equation. I wouldn't feel like you doing it over and over gives you any insight into what's going on. But I do want to point out this. I don't know if you guys remember the formula for standard deviation from forever ago. Maybe not. Remember when we had to do it in the tables?
Yeah.
Right? And there was, I can't remember the book said this, and I don't think I said this because I just tried to get to the point. But there's a different form of that formula. So just to remind you guys, it looked like this for a population, for example. Right? This would be the variance for a population. You guys remember that? All right, cool. There's a different formulation of this. If you work this out a little bit, if you FOIL this and do all this stuff, you get this here. Oh, let me see. It's been a while since I wrote this down. Well, that would be just over n for that. Let's do, well, for s, it would be over n minus 1. It doesn't matter. But it's basically like that. So look at the top here. Look at this. And look inside here. Do you guys see what I'm trying to say? So what did I say the R was sort of like? It was sort of like a two-dimensional standard deviation. So look, it's got the standard deviation in the x direction. It's got the standard deviation in the y direction. It's got both of them in there. So that's the only thing that I see in this formula that's useful to point out to students is it's built in. It makes sense. That's another reason why I think of it as a two-dimensional standard deviation, because it's got the x and y standard deviations in it. It's also got what's called the cross terms between the two. So it's got more shit in there.
We're not going to actually be using that formula or something?
No, we're not. We're not. I like it. So you can stop looking at it if you want to. I'll take it away. I'll take it away. Whee! So here's the thing to think about, though. Help me out here. If I had data that looked like this, what do you think that would be? Is that r equals 0, r equals 1, r equals negative 1?
R equals 0.
Because what this means is, this is sort of like how high I can jump versus the height of the building over there. So I'm like, let me make that building taller. I'll jump. Oh shit, let me try. So I don't care how tall I jump, how high I jump, the building's height doesn't give a shit. Right? If it did, that'd be a very strange world to live in. You guys understand what I'm saying? So there's no relationship here. There's no relationship between how high I can jump and how tall that building is. That's what this would mean. So people would say, well, that's a straight line, Jeff, but it's not a relationship between x and y. What would the equation of this be? Let's say the height of the building, I don't know, I can't guess it. 60 feet tall. So what would the equation be for this?
Y equals 0. It's 60.
Y equals 60. That would be an equation. Does it care about x?
No.
No, so it's not a relationship between x and y. Y is always 60. So I don't care that it's a straight line. It doesn't mean correlation. All right, so if you put this data in your calculator, it will come out with r equals 0. And the other one, of course, would be a vertical line. That would also be r equals 0. Okay. So let's do this. If you look on the back of this, I've got some data that kind of goes along with the real life analogs in the front. So we're going to do this together. If you need a calculator, again, there's several up here. We're going to do the calculator right now. So Here, I'm going to have to catch up to you as soon as the computer warms up. But if you have a calculator, you want to put the number of beers in list 1 and the number and the grade in list 2. Do you think you ever want to sort this data?
No,
Why not?
because they correlate.
Exactly. I don't want to break the points up. 2.7 goes with 71. If I sort them separately, then everything in the world is going to be correlated. You know, everything's a straight line. No, no, no. You got to keep the points together. You don't want to sort this ever. Oh, good. I can catch it. Hold on. Don't freak out because you all should have the data in front of you. I appreciate that. I always want a couple of smart-ass students in class. But don't be worried about the future of the world. We need smart-asses. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. So it's always nice to know how many total points there are, so you at least know you have the right number of points in there. Alright, I got it. So again, please, dear God, don't sort this. So here's how it works. And you all have this on the Calculator Bible that's on the website, but you also, I just wrote it again here. I didn't write it, I just copied it. The procedure for what to do in the calculator for this. You can use this on the homework all day long. You cannot use this on the test. You can test your ability to remember how to do this in the calculator. So here we go. If you hit, some of you guys, well, just go with me. We're doing a technology thing, so please, dear God, tell me the minute your calculator is telling you something other than what I've got. Here we go. It's stat, calc, and which one of these makes sense for finding the equation of a line? Probably the one that's got a line. Or? Yeah. Now, I love this. Look at option 8. A plus bx versus ax plus b. Do not ask me why they hardwired it. Two different. You guys with me? So in this case, what is going to be my slope? What's going to be my slope?
Or A.
A is going to be my slope, right? mx plus b. You guys remember that?
Yes.
And you're like, what? It's got uses outside of freaking algebra? Yeah. So if we hit number 4, it defaults to list 1 and list 2. So as long as all your data is in list 1 and list 2, you can just hit enter. Just like one var stats defaults to list 1. So if you just hit enter, some of you are only going to have this, and some of you are going to have more. So don't freak out if you have r squared in r. If you only have what I got, I'm going to show you what to do. You only have to do this once if you have your own calculator. Are you guys kind of with me? Does everybody at least have that showing up?
No.
Show what's going on. Let me know. Where are you? Who said no? Oh, damn it.
I did the wrong one.
What's up? Oh yeah, does yours look different? The newer ones might have a different. But I mean, getting there. It asks different
You're
questions.
going to put L1 or what?
Okay. Oh yeah, it had like a. Okay.
L2 and L2.
Yes, make it L1. All right. Who else? Anybody else? Oh. Yeah. Oh, Shisa.
I bet you what you
As long as you get lucky, you're going to
I'm so shocked.
I don't know for an adaptive chapter or 130. The one thing that I
Alright, guys. Everybody! So how many guys got more than that? Okay. How many guys got more than that to show up? Anybody? Everybody only get this? Nobody got anything else?
Yes. I did, but I followed from the sheet, so it's got more sense.
Oh yeah. So it's got what to do. I think I put what to do. Yes, I did. Alright, here we go. You ready? You only have to do this once. And as Moy pointed out, it's actually on the sheet, but we'll do it together. You ready? You only have to do this once, so I don't just do it. Here we go. Second, 0. This is the catalog for every function that your calculator can do. And see how there's a little A up here?
Yes.
So that means it's alphabetical now. So if I hit the D button, do you see the D button is right here? See the little green D?
Yeah.
Then hit that button. It's going to go to the D section. That's amazing. Scroll down to where it says Diagnostic On. That is obviously what's going to make R show up. No, it's not. I'm joking. I don't know why they call it that. Don't freak out. You just do it and and forget it. Set it and forget it.
Okay.
Diagnostic On. Enter. Very anticlimactic. Are you all with me?
Yeah.
Go back to Stat Calc number 4 again. And now you guys should have all this showing up.
Yeah.
Is everybody with me? Let me know if you're not.
Okay, I just turned on.
What's up?
Oh, okay.
I don't know, I just took it.
Oh, 3.
Yeah. When in doubt, you just go for it. If you notice, like others. Oh, here it is.
Not 176. I got placed in 180 though. No, I got placed in 178. Oh, 178. That must be pre-count. That is pre-count.
Alright guys, stay with me. This gets even more impressive. You're like, hopefully so, Jeff.
I did also trigonometry, I think, in
Probably what happened is
It's never went out.
Alright. Here we go. You ready? I don't care if you're ready, you're going to do it. So what I want is 2 things now. And I'm going to show you exactly what I need to see on a test. So on the final, you're going to have to come up to me with your calculator and show me what we're about to get on my calculator. Or not, and just lose the points. It's always up to you. So I need to get the scatter plot. And what I mean by that is I need to get like the little blue points. right? The little blue measles that are on the paper, right? And then I also want to get the straight line equation. I want to get that to show up on my graph too, right? Real quick, can you guys tell me, we still don't have a feel for this obviously because we're brand new to R, but does that seem like that's telling me it's a good fit? No, of course not, because it's not close to what? In this case, it's not close to negative. It's too close to 0, though. It is close to 0, which means it's really close to not having any correlation. But the little bit of correlation it does have is a negative correlation. Oh, okay. Yes, sir.
Going downhill a little bit.
Yes. Which is good, because that's the number of years versus grade. You know, if it was the other way, I have a bunch of drunk students showing up and, all right, it's an 8. So the way to get the stat plot, the scatter plot to show. See the y equals? It's seconds, y equals. Alright, so let me know. Has everybody got that showing up?
Yeah.
Let's play it along. Alright, so all these should be off.
Second.
Are all of them off for everybody?
Yeah.
My number 5 is on.
Mine is on.
Number 5 is the way to turn them all on. There's only 3. So everybody right now, just hit number 4. Everybody just hit number 4. Enter. There you go. Now they're off. If any of them were on, they're all off. Yes, sir.
What's on y equals?
Second, y equals to get in the stat plot. Right, that kind of makes sense. I want to plot some statistics, so I go to stat plot. Everybody should be off now, right?
Wait, why 4 out of all of them?
Because 4 is the one that turns your plots off.
Don't worry about 5.
Hey.
Is that it?
No.
Oh.
4 is the option that turns the plots off.
I understand.
5 is the option that turns the plots on.
Okay, I get what you're doing.
Huh?
When you press into all 4,
Alright. Everybody alright?
Yeah.
that's all off.
Oh, 5 turns them on. Gotcha.
So everybody pick number 1. Pick number 1. First thing we'll do is we'll turn it on. Bam. I just did something wrong. Go back to 1. So highlight on and hit the enter key. There it is. So now on should be highlighted. Mm-hmm. Keep going, math boy. Make sure that the first thing here is the scatter plot. Make sure that's highlighted. If it's not highlighted, just cursor over it and hit enter. Make sure it's L1 for the X list, L2 for the Y list. Cool.
Hey, now.
Everybody alright? And then you get to pick if you're a square, are you a positive person, are you a speck of dust in the universe? I am, of course, a square, because I teach math. So now, if you hit graph right now, and you're like, how much does this thing cost? What the freak, Jeff? Well, the problem is, what's up? Yeah, does it look like mine?
What's there?
I noticed there.
Oh, you got something in your y equals. So let's do this. Hit y equals by itself. Make sure all of these are empty.
Oh, yeah.
Are all of them empty?
No.
Yes.
If they're not empty, make them so.
Okay.
So here's the problem. When you put data in, the calculator doesn't know you want to see it. The calculator just shows you the window wherever it is. Right? So what I do is I do this. I go to zoom, and which zoom do you think I use? Nothing on this page.
Out.
Hit up, hit the up arrow, and then it's going to become very obvious. Zoom stat. For me, it's number 9. Depending on what's going on with the calculator, it might be different. But zoom stat is what you want. How we doing? You guys?
What 100?
I always love Technology Day because so many things could go wrong. Everybody all right? What's up? So let me get it. So if you hit zoom stat, this should happen.
Yeah.
Still not working.
Did you have your plot turned on?
Yeah.
Oh, window range. Oh, I see. It didn't work at all, did it?
No.
So if you hit zoom 6, that's zoom 9 actually. Just hit zoom stat. It'll set, because right now the window is set weird. hitting zoom 9 will make the window so it fits all the data.
I hit it.
You just go.
It's gonna press zoom and then 9, like little zoom and then 9.
Oh, 3 places. Yeah. I don't know if you guys have noticed this, but there's like a lot of different number of places. Z-scores are 2 places, obviously, because the chart's 2 places. Guys, hey. When in doubt, just go 4 places for everything. You know what I'm saying? Because what's probabilities? I want 4 decimal places, right? Standard deviation, I want at least. So 4 would work. You with me? So if you're in doubt, you're like, what the hell? Just go 4 places and you're fine. You with me? 4 is fine. 8 is crazy. So what's missing from this? Why would this be not good to come up and show me?
Because there's no line there.
There's no line in there. In fact, we don't know this perfectly yet, but do you think I would trust the line from this? What did we look at that told us that we wouldn't trust the line? What's not quite where it should be?
The R.
The R is not strong enough, right? The R is a measure of how strong the fit is. And does this look like a straight line? This looks more like just somebody just threw darts, right? Now again, that's an outline. If I took that out, does it look like a straight line then?
No.
More. Can't you see it better there?
Yeah.
But it's because of this guy for the most part, and of course that person's not helping either. If I took both of those out, it would be a nice straight line, but then I would be dishonest, right?
Yep.
Okay. So here we go. Here's how you put the line in there. Probably nobody wrote that line down. Let's go back. Go to Stat, Calc, number 4 again. Let's get all that back. What is my equation of best fit? What's the line of best fit equation? I'm going to write it up here for myself. You guys help me. What's the slope? Yeah, because y, holy mackerel. Okay, poor little thing. Y equals ax plus b. So y is